Okay, guys. I'm gonna record this. I was gonna record it in class, but my internet kept going out. So hopefully we get through this now. Okay, so we're gonna learn how to count atoms that show up in an equation. Now, how to count atoms like this, we should already know how to do, okay? But it gets a little more complicated and you'll need to know how to do it for our stuff that we're gonna do next week. So in this one, this is easy. This is just a review of stuff we should know how to do. We have an element, this is a subscript, and it goes to the element that it is next to. The element that's in front of it is the one it goes with. So there's one element in this. This isn't really a compound, it's a molecule, but this is sodium, and that 4 goes to it, so there are 4 atoms. So then how many total atoms is it? 4. Easy. Okay? Now, then the next one over here, a little more complicated. We're having this thing that you haven't seen yet, or you might have seen it, but we haven't talked about it yet. When we start doing those chemical equations you saw yesterday with the different types of reactions, with the something plus something yields, so it has that arrow, something else, those chemical equations, they start putting these things in front of the compounds, these numbers. The numbers are called a coefficient, okay? So we had subscripts down below, sub means below, like a submarine, so subscripts down below, and we have coefficients in front. The coefficients in front of a compound go to everything in that compound. So this is the whole compound, so that 5 goes to the calcium, and it goes to the chlorine, okay? So how many elements are there? There's 2. There's calcium and chlorine. Let's write those down. It's calcium and chlorine. Now to figure out how many atoms there are each. First off, this 5 is in front of the calcium. I told you it goes to everything that's inside that compound that's in front of. So there's 5 calciums. That's it. And then for the chlorine, well, it already has a 2. It has that 2 subscript already. Now you do not add. It's not 5 plus 2. It's always multiplication because I have 5 groups of CaCl2. I have 5 groups of CaCl2. So I have 5 times 2. It's always multiplication. So 5 times 2 is 10. I'm going to end up having 10 chlorines in that little group. So my total number of atoms is 15. Okay? I'm going to scroll down. You will have to pause if you needed to keep writing because it's going to move it. Okay. So now we're over here, same thing. I have carbon and oxygen, so that's 2 elements. I'll go ahead and write them down. I have carbon, and I have oxygen. All right. Now the 2 goes to everything that's in front of us, so the C and the O, goes to everything in that compound. So the 2 goes to the carbon, but the carbon only has a 1, so it's just 2 times 1, which is 2. So there's just 2 carbons. There's already a 3 with that oxygen, so then 2 times 3 is 6. Okay, so we have 6 oxygens total. Now it's going to get a little more complicated. Okay, so when we start seeing these things with these parentheses, we have this with the parentheses around it, that's when it's a little more complicated. It's not super complicated. It's still just counting atoms, not that bad, but it does add a little bit more of doing the right kind of math in order. Okay. So let's go ahead and count our elements. We have cobalt, we have phosphorus, we have oxygen. So we have 3 elements. Let's write them down. We have cobalt, it's our metal. We have phosphorus, and we have oxygen. Now, phosphorus and oxygen, they're in a polyatomic ion with each other. They're in a polyatomic ion called phosphate. But when I write them out, it's cobalt, phosphorus, and oxygen. Okay. So this 4 is a coefficient. It goes to everything in the compound. So it goes to the cobalt, it goes to phosphorus, and it goes to the oxygen. So I'm trying to figure out the cobalt. Cobalt already has a 3, and I have 4 groups of the CO3PO43. Okay, so I have 4 groups of those. So 4 times 3 is 12. You end up with 12 total cobalts. Now for this phosphorus. A little complicated, we have these parentheses. This 3. Remember in math, you got to do the parentheses first. So this 3 goes to the phosphorus and it goes to the oxygen. So I already have the 3 going to the phosphorus. So I have a 3 here, really. And then we have the 4 times 3. So it's still always multiplication, just that 3 had to come in first. So I have 3 times 4, which is also 12. So there's also 12 phosphoruses. All right, last one is this 3 also went to the oxygen. This 3 also went to the oxygen, but it's multiplication. Parentheses means multiplication. So we're not adding here. It's 3 times 4, which is 12, and then that 4 also tacks onto it, and it's always multiplication. So we have the 3 times 4, which is 12, and then you have the 12 times 4, which is 48. So there's a whole lot of oxygens. So when I add all those up, you got 2, 4 plus 8, which is 12. And the 1 comes up, so 1, 2, 3, 7. So we have 72 atoms total. Oh, I forgot to add these up. So 2 plus 6 is 8 atoms total in that compound, or in that group. Okay, last one. I gotta scooch it over, and it's actually a little easier than the one we just did. The one we just did was the most complicated. Move me over. There we go. So last one, the same kind of situation. We have the parentheses going on, so we got to make sure we account for them in the right order. All right, so we have calcium, we have oxygen, we have hydrogen. That's 3 elements. So I have calcium, I have oxygen, I have hydrogen. Okay, so I have calcium, I have oxygen, I have hydrogen. So for the 3 in front, remember it goes to everything it's in front of, so it goes to Ca, it goes to O, it goes to H. So when I have the calcium, it's going to be 3 times the subscript, which is 1. So 3 times 1 is 3. But then I come into those parentheses. So when I have these parentheses, I have to do the number outside of it first, because that's PEMDAS rules, parentheses first. So the 2 goes to the O. So the 2's already there with the O. Then that 3 in front can multiply with it. So 3 times 2 is 6. Getting a little messy. Okay. And then that 2, again, comes the hydrogen. So it comes there first. So I got a 2 going on with this hydrogen, really. And then 2 times that 3 in front is 6 again. It's also 6. So for my total atoms, I have 3 plus 6, which is 9. 9 plus 6, what is that? 15. Okay, so we have 15 total atoms in that compound. There you go. So just a quick review of the kinds we've already done with counting atoms, and then adding those coefficients in front, because we will be adding those coefficients in front starting next week when we start balancing equations. Okay, so there we go. We end this recording.